Psychedelics induce a primitive state of consciousness by relinquishing the ego's usual hold on reality. This is the central hypothesis of the Entropic Brain Theory, a theory proposed by one of the leading psychedelic researchers, Robin Carhart-Harris. It combines biology, psychology, and a little bit of physics. The theory suggests that our mental state can range between highly ordered and highly disordered brain activity. The point between chaos and order is known as criticality, or primary consciousness. In this state, we experience creative, flexible, and adaptable ways of thinking. Small thoughts can spark major insights, and the brain becomes highly sensitive to its environment. It's a state of mind that is hyper-associative. Primary consciousness is what we experience during the psychedelic state and also during REM sleep and early psychosis. In contrast, our normal waking consciousness lies just to the right of primary consciousness, slightly more towards highly ordered. This is also known as secondary consciousness. This helps us manage daily tasks and limits uncertainty and surprise in situations, but can also narrow our conscious experience and lead to having rigid beliefs. According to this theory, one of the key differences between secondary consciousness and primary consciousness states like the psychedelic state is the level of entropy in the brain. Entropy is a term that's used to describe how chaotic or ordered activity is. Normal waking consciousness has lower entropy, keeping things more predictable, and so there's less uncertainty, while psychedelics increase entropy, making the brain more flexible and fluid. The theory suggests that there are some parts of our brain that are suppressing entropy in other parts of our brain. One of the brain regions they suggest is important in suppressing entropy is called the default mode network. It's involved in introspection, daydreaming, mind wandering, and metacognition, which is our ability to reflect on our own thoughts. The theory suggests that the default mode network sort of acts like our brain's ego, suppressing entropy in other brain regions, especially the medial temporal lobe, which handles things like memory and emotional processing and regulation. Under the influence of psychedelics, the hold the default mode network has on the medial temporal lobe loosens, allowing the medial temporal lobe to act more independently. This also allows the brain to enter a more entropic and creative brain state. The author compares the level of entropy in our brain to the richness of conscious experience, making the psychedelic state feel far more profound than normal waking consciousness.